Like most communities, we in New Providence use water in a variety of ways. Most of us have a pretty good idea of where it comes from, but you give any thought of what happens to it once it flows down the drain. Today, we're going to join members of the Borough Council as they take a tour of the New Providence Wastewater Treatment Plant. The treatment plant is a short ride north of downtown. It's located at the end of Park Place, just off Commonwealth Avenue and adjacent to both Oakwood Park and the Passaic River.
Hi, I'm Anthony Carnevale, licensed plant operator for the Borough of New Providence Wastewater Treatment Plant Collection System. I'm the licensed operator for Summit's 4 pump stations and the licensed operator for their collection system. Currently we have a staff of 3 full-time personnel beside myself and a part-time lab tech. The plant, built in 1936, was upgraded in the 70s and then upgraded again in the mid-90s. Currently we are one of 3 intermittent discharge facilities, which means that we don't flow to the Passaic River on a daily basis, mostly during real wet weather events and snow events. When our flow coming into the plant surpasses 3 million gallons, we end up having to discharge and treat the wastewater that's going to go into the Passaic River. The Borough of New Providence has spent millions of dollars on lining, trying to cut the infiltration that is entering into the sanitary sewer system here in town. Borough residents could be of a huge help. If you have an illegal sump pump that's hooked up to the wastewater collection system, you can call down here at the wastewater treatment plant 908-665-1077, and we'd be more than happy to assist you and direct you in how we can correct that situation. One illegal sump pump adds a significant amount of water into our collection system. So, if you have a real lot of houses that have illegal sump pumps hooked up, that's increasing our flow significantly. Disposing large, rags, paper towel, large paper towels and stuff, flushing them down the toilet and stuff, it could be causes us a real problem in the collection system. Also, grease should be put in maybe a coffee can and disposed of with your trash. Pouring it down the, your drains not only is going to affect your lateral coming out into our sewer main, but it has a major impact, in the sewer main itself. If you have a problem, a sanitary sewer problem, you should always contact, the wastewater treatment plant first, which is 908-665-1077 from 7 to 3:30, and after 3:30, if you call the police desk at 908-665-1111, they will reach out to us and we'll come out and make sure that the problem is not in the borough sewer main, and probably could help you determine what your problem is and help direct you from there. This is I just wanted you guys to see this. This was the beginning of Hurricane Floyd. So this is, our chart can go up to 6 million gallons. That's as high as we can get. So you can basically see at 8 o'clock we were pinned at probably, wow, God only knows, and then we started to drop off, and this is million gallons. And then what you're looking at on the first chart is your red pin is the Constantine force main line that I was talking about. It can pump up to 1 million gallons. And then this is the other force main that runs from here to Morris Avenue, which has the ability to pump 2 million gallons. And this is your green line, is your total flow for that day.
So Tony, the red line on the first chart, that was the total flow through the pumps in the plant?
This was basically the influent coming into the plant. And then this is our 3 million, and then really what I would have to show you is our effluent chart. And then what Mike is saying is, you know, you're looking at the chart and we have plus, you know, we're I would say probably close to 8 million gallons probably coming in that day. So here you see we have, this is the effluent chart, and this is what is actually going to the river. So we have almost 5 million going to the river, 3 million going to Summit, which is a total of 8 million, and we probably got close to 1 million recirculating through the plant, through the filters, and being just like processed around. And then again, when we're in this, and I think we've had 6 discharges, which is a kind of a high number for this year. But you know, when we do have them, you know, we have to fulfill our requirements for our DEP permit for the DMR and WCR, which requires testing. So.
And you have to report them as they occur.
Yeah, I got to do a DMR every month, regardless if we have a discharge or not. But yeah, it's obviously it's a lot more work, but there's a lot of mathematical stuff that has to be done to get your, you know, what your total test results are.
Anyway, that's why we spent a little more to do.
And then I put this here. I'm going to go over some of this. I'll do it later. But you know what Mike's talking about, and I was talking to some of you about. You know, vitrified clay pipe, 3-foot sections. This is actually a blockage. That's a total root mass that is through that pipe. And then you can see in this picture, they're not great because we took them off of the actual camera in the truck, but this is the cutter that we got going through there to cut it out. So you see it here, and then we'll go in with a hydraulic root cutter. And then with that cutter, you know, we'll start maybe 4 inches, 6 inches, 7 inches, and we'll try to open it up as much as we can. Well, we were talking about lining, and the borough has spent a lot of money. And when you read the report, you know, like we were talking about, all that infiltration, you know, that gets in through the sewer system, being that we have 85% vitrified clay pipe, you know, on a normal day, if the ground is a little bit wet, we're doing about, on an average day, 1.5 million through the treatment plant. If we get 1.5 to 2 inches of rain, that flows up to 4 or 5 million. 3 inches will take us over to 6. The plant can do 3 million gallons. When we get past that, we have to, a lot of times, I shouldn't say that, a lot of times we get lucky, we can recirculate, we use our secondary clarifier, we kind of keep it empty to give us another couple hours of holding time. And a lot of time, if stuff starts to recede, we'll get it to the back, we'll be able to keep recirculating, and we will not have a discharge event. And that's always our goal. But sometimes you get overwhelmed.
The tank goes about 450,000 gallons?
Yes, yeah, the secondary
So that
clarifier.
gives them some relief.
It's about 2.5, it's like almost 2.5 hours of time, depending. Like during Hurricane Irene, that tank filled up the fastest that I can remember. So, you know, it's, like I was saying, it's a unique plant. There's only I think there's only 2 other ones in the whole state that are like it. We're really a pump station / wastewater treatment plant. And our goal, and the borough spent, you know, a lot of money on lining, is to eliminate what we've done most of the work on our end as far as going out and finding the areas that we need to, you know, take care of with lining that'll prevent infiltration in some of the real high maintenance areas. And we continue to do that. And we have seen reductions in flow, and without a doubt, less discharges. This has just been a crazy year. But until we tackle the illegal sump pumps in town, the borough's kind of spending all that money, and you're losing the battle, because one sump pump running, you know, is putting hundreds, if not thousands of gallons of water into the sanitary sewer system, which we got to treat down here. It's going to come down here, and we got to process it.
It costs us money doing that.
Yeah, and we know where there's a lot of them already. You know, through lining, we've been able to, you know, identify some of them, which, you know, I have on record, and we're looking at how we're going to go about doing that. And, you know, it's going to be a lot of labor-intensive work, because you can do dye testing, inspections, you know, smoke testing, which we have the ability to do. And we are going to definitely do that, but we're just right now a little swamped, and when we catch up, that's something that we're going to try to do. I have some ideas of even bringing some college kids in on a part-time basis in the summer that we can train to go in and you know, set up inspections where they can go in and look. So we're gonna have to look at a lot of, you know, a lot of different options, but it's something we have to attack. All right, so we'll start down below. We'll start at the beginning and work our way up.
So that's the liner.
Yeah, it starts off like a bag, and then they inflate it and cook it, and the epoxy resin that's in it hardens.
What you're basically doing is you're eliminating all the joints, and you have a solid, brand new piece of pipe inside the existing pipe from manhole to manhole. So as long as your lateral cuts are good and stuff, you're going to prevent, you know, having that infiltration coming in. This is our emergency generator. You guys are probably aware that we're having a problem with the radiator. The radiator, as you can see, is very large. It's like 6 feet by 5 feet. It's back here. This is one of the most critical pieces of equipment we have. If we lose power, like I said, we've had over 23 power failures to date here at the treatment plant. This is the most critical thing, because if this doesn't run, we can't move the wastewater that's coming in.
How often do you exercise this?
Normally once a week. Under a load. This is a load bank right here. It puts a load on it, which I think is really important, because you know, you can run your generator without a load on it, it's going to run fine, and then when you put a load on it, all of a sudden it's not going to operate the way it's supposed to. So but since we've had this till we get this radiator, we've kind of slowed that down and been doing it like, you know, once every month, because we don't want to take a chance of blowing this thing out totally.
And we have a contract with a maintenance company
We have,
that checks this out?
Yeah, RJ Controls. I set that up. It used to be twice a year. I made it, you know, quarterly, and we're still saving money with the company that we're using right now. So, you know, again, we come through here ourselves when it's running. We have a checklist over there. Basically go through, checking amperage, volts, you know, oil temperature, you know, a bunch of different things. And this way, if we see something that's out of whack, we know that, you know, something's not right, and we're able to address it.
How long do you run the test for?
It's a half hour.
Half hour?
Yeah. And, you know, it's basically, I'll take you over to the switchgear, which is the next building over, and that's where, you know, the power switch takes place. And that's kind of what I was talking about, a problem that we addressed in Summit at Constantine Place. You know, that's, well, basically what they had at Constantine Place was, when I took the station over and I knew going in, their Cymax processor was in halt and the memory was corrupt. They basically, for the last 6 or 7 years, did not have that operating in an auto mode. You had to manually go in and do it.
So what normally happens when there's a power failure, there's an automatic transfer switch that senses it, isolates the plant from the utility grid, and switches it over to this power supply. And that happens very quickly. Within a matter of a minute or so, you're up and running again. But when the automatic transfer switch isn't working, someone has to come over here and manually do that. And then it all depends on how long it takes the person to get there. And then once he does, he's got to throw the switch, start this up. You could be talking at least a half an hour.
Yeah, if not more. And if your wet well doesn't have the capacity, you're going to flood. So, you know, that was a very important thing, and we were able to, you know, reprogram the processor over there, get it at a halt, and then we found a bad 2447 monitoring relay that was in the system. We were able to come in and get a new one and repair it, and we have that thing up and running the way that it should be running. And that makes me sleep a little better, because, you know, it's my responsibility now, and, you know, that was really an important thing to get done. So, all right, and I'll take you over to the switch gear. So this is our switch gear, and Mike was just filling you in on this. You know, this is JCP&L's power source coming into which is running our plant and the other buildings down here. This is a breaker, and this breaker would be closed, and you would have your power source coming in. This breaker over here, which is open, is the generator breaker. And this is not, when it's open, it's not operational. What you have here in this board is the automatic transfer. And how that works is, this is a, you know, a Cymax system. This is a processor. You have your I/O cards. This is the brains of this system for as far as switching. This is what's telling everything what to do. This is also tied in. This, if not operational, what we were talking about before, is you would manually have to come in here. You would have to open this breaker and close this breaker. If it's not operational, you know, that's what you're going to have to do. And like Mike said, somebody has to get here. You know, make sure you can't just come in here. One of the big things, I try to tell my guys the same thing, you have to slow yourself down. You can't just come in pushing buttons. You really got to look at everything. Make sure that you know exactly what's going on, because if you make a mistake here, you're probably not going to be here to tell anybody how it happened. So this is very, very important.
What's the voltage coming in there?
Well, here's the monitor right here. 480 is what we're kind of running around.
Right.
So, you know, this is another thing. This is a power logic monitor. This is going to tell us what our phases is coming in. You have 3 phases, and you can go through here, and it basically tell you what each phase is bringing in. Most of the stuff in the plant runs on 480. And this is the switchgear room. And also down below we have a battery backup. If you lose power, you know, this is for DC power, and then we have another battery backup right there. So the delay that Mike's talking about, something has to keep this alive, and that's what this does. So this is another something a lot of people might think, you know, you look over, but having these batteries backups working properly and making sure that, you know, the batteries are changed every 2 years is critical. Because if this thing, when we lose power, if there's nothing that can power this, it's going to be dead and nothing's going to happen. So that's another very important, you know, part. And we have them throughout different areas of the plant that we got to make sure that we have them working.
And then once all the current gets through this switch here, it comes over here and goes
Yeah.
to circuit breakers and gets distributed to each of the different buildings in the plant.
One of the things that we do is almost as much as we humanly possible, we do all our rebuilds, you know, repairs of equipment and stuff in-house. Sometimes, you know, we have to send it out if it's a motor or something, you know, that has to be rewound, baked and all that has to be sent out. But overall, we keep you know, parts in stock, and the downtime on a pump, basically we could probably turn it around in, you know, 6 to 8 hours and have it back up and running. You know, it's another thing that I'm going to try to implement in Summit. They don't have any parts on stock. Some of this stuff has to be made. The lead time can be 2.5 months to get a piece. So this is basically our control panel for this building over here. You get an alarm. You basically, this is programmed down to the main process control panel downstairs. You would come in if you had if our commutator channel monster was jammed. Basically, you would come in, this red light would be lit. You would want to go downstairs, evaluate what happened, you know, before you reset this alarm.
Why don't you tell what the channel monster does? So,
yeah, we're gonna go down there. It's gonna be a little noisy down there. This is our flow coming into the plant. So right now, it's saying that we have 2.6 million coming in. This is not a true number because obviously it's over a 24-hour period, but that's what they're saying is coming into the plant right now. This would be our Constantine force main, which is cycling right now. We don't run it all the time unless we have a lot of flow coming in. And this would be your flow to the river. And this important number is the inches of the wet well, where I'm going to take you guys down next. Basically, we're trying to maintain, you know, between 39 and 40 inches in a wet well. And the pump is designed, our low lift pumps, to basically maintain that level, which is the low lift pumps. This is a controller, and right now we're running at like 74%, so that's what this needs to do. And the reason is, inside here is what you got. I'm sure some of you have seen some of the stuff that's been, you know, reports that I've sent about VFDs, variable frequency drives. This is a VFD right here. This is basically controlling the speed of the motor. This is really kind of the brains for how that motor is going to how that pump is going to operate, pump and motor. So we're able to go in here. We can adjust hertz settings and different stuff if we want to increase or decrease the flow. Just watch it. Yeah, I know. Basically, this is where it really all begins as far as the wastewater traveling through our collection system in the borough, and ultimately it makes its way down here to be processed. This is a confined space. Obviously, when I talked about the generator, if it didn't work, this was where we would start to fill up, and that's why you have this door here. And early in my career, I think I was here a year or two, I came in on an alarm and was trying to get this open, not really knowing at the time that this thing had water, you know, up above. So, good thing I couldn't get it open. I might not be here right now. This is a monitor for the wet well. Basically, before any of us go in here, we have to make sure that hydrogen sulfide, oxygen deficiency, or an enriched environment, or methane, there's a log there to fill out. Basically, you want to make sure this is safe to go in, which it is right now. What you see here is what we're talking about: grinders, channel monsters. Basically, what you have is you have your raw storage coming in. Over here, you have two channels. There are grid chambers before the channels to catch some of the grit that's coming through, which has to be manually cleaned. Any large debris, a lot of different things. basically, that's why you see all of the different bolts and the stuff. We got to pull these apart. A lot of debris builds up inside of these, and we have to basically cut it out by hand, clean them, and put them back together.
So like that one now, that comes out really soft.
Shut. Basically, depending on how fast the pump is running, is how much open this check valve will be.
Not the facility, right?
We have a problem. Usually, it's something we got to send out. A lot of times when these go, it's an overload inside. It can be something in the windings, and we really just don't have the ability or the technology to do that. So, something like this we would have to send out. Over here. These are the hydraulic units that run the channel monsters, the cutters. Yeah. Both of them are running right now because we have a little bit more flow coming in. Normally we run one at a time. Basically, oil changes, once a year on these particular units. Change the filters, the oil, go through the lines, make sure we don't have any leaks or cracks. And this is actually what controls them channel monsters downstairs. That's an old coal chute. Back in the day when they had the old, boiler, they had to shovel the coal in. This is how it got down here. Just blowing air out of the well, bringing it up outside. This is the effluent chart for what's coming in to the plant. And right now we have 2.5 million coming in. This is changed on a daily basis. Somebody will come in, they'll take the numbers, or the numbers are on the back of this chart from yesterday. They'll take these numbers down when they come to change it at 7:30 in the morning, and then we'll take them two figures, and that'll give us our total flow for the day.
You tell me normally, do we get a heaviest flow in the morning?
Our peaks are between 8 and 9 o'clock, and really you have another peak 5, 6, 7 o'clock, and then you'll get a little spike at 10 or 11 o'clock, and then you'll start dropping off.
The biggest peak is halftime at the Super Bowl.
Yes, that's a big one. Yeah, and the funny thing is that, doing this as long as I've done it, I've been here New Year's Eve, I've been here Christmas Eve, I've been here a lot of times. I think 3 New Years I was on a sewer blockage or a plant alarm when we were rigging in the New Year. So it comes with the job, and that's the thing. Joe's been real dedicated since he's been here, and that's the kind of guys that we have to have down here, because it is a demanding job of your time, and you have to give a lot of your personal time up. These places are utilities that run 24/7, 365 days a year, and they have to be monitored, and emergency response is a huge part of this job. So we've added 4 more utilities in Summit, and so that's putting a little bit more pressure on us right now. But once we get the plants up running the way they should, some of that. We took it over September 1st, and I think we've had 5 or I think it's 5. It's probably 6, including yesterday, after hours emergencies already. So it is demanding, but we got a pretty dedicated crew here for that. So, all right, we'll go up. As you can see, this is our settling tank right here. I dropped normally you can see where the level is. I dropped it last night because it was calling for heavy rains, and I tried to get this tank down as low as I could to buy a little bit more time if we started to fill up. This settling tank basically takes the settable solids as the wastewater is pumped up with the pumps that we were looking at downstairs, 3 pumps. That's what brings the wastewater into this tank. then what happens in this tank, your settable solids go to the bottom, and your suspended float to the top. And as you can see, suspended is grease. That's what you're looking at down there, and a lot of other debris. Down below, fluffy grinds, all kinds of filter. There's a whole bunch of stuff that settles out to the bottom. You see the arm going around? The arm basically has there's a blade on the bottom. It takes about 20 minutes to make a total rotation. And what it is it's taking the sludge off the bottom of the tank and pushing it into the hopper. And then down in the building where we started this tour, there's a pump down there that'll take that, grind it, and basically send it over to the force main pump that goes to Summit. The grease,
the tank that the valve needs to be replaced on?
yes, our sludge return valve.
Right.
This right here, once every 2 weeks, we'll bring this tank up. I'll raise this tank, and then you see the little hole on the side. Basically, we will take the grease, and that's how we get the grease out. Basically, it goes down through the pipe and downstairs where we started, and goes through the aerator where it's chopped up real fine, and then inserted into the force main pump. One of the things we do try to do is, if we know a wet weather event is coming, we're going to get heavy rains, there's a good chance this is going to fill up. We try to get the grease out so that when it does go over here, we don't have this whole thing filled up with grease and let a lot of that stuff get into the rest of the process. So it's important that we maintain this as far as what's on top.
Normally this tank is full.
Yeah.
The water will flow over that into this piece here. And see these V's? Right. It's called a V-notch weir. And the elevation is set so that you will get a certain amount of flow when the water's at the top of the weir, and that's how you control the discharge out into this channel.
So this, I guess, with the hurricane was...
Yeah, what happens is, and I should explain this. This tank, normally I maintain about 63 inches in this tank. When we get heavy rains, obviously this tank starts to fill up, and it's 333 inches to get to this weir that Mike's talking about. Once we get over the top of that, we are now going, if we walk around to the other end, I'll be able to show you. So when this fills up, when this comes over the top, and we're going, what we're basically doing is we're going to that tank right there that's empty, which is the other settling tank.
It's the one with almost flying, right?
Yeah, well, we're going to have to do something with that tank, but basically, to keep it empty, that tank, like I was talking about before, is to buy some time. So when this goes over, I know that when this is over, I have about another 2.5 hours of time before we're going to actually go to the back chlorine contact tank, which is in the back. These filters right here, basically, you have your media. This is plastic. This filter is filled up with plastic, and then on the bottom, maybe you have about 4 feet. You have a screen down there. The water trickles through, and basically, what the green you see on there is like a Google map, which is a bacteria that's built up on the media, and as the water trickles through, it actually removes other bacteria. The filter down over there is a rock filter. We're getting a lot of algae, which we're going to have to go up there and manually clean out, because we don't want cooling and stuff like that on the filter. But that's doing the same thing. And those rocks that are in there basically have bacteria built up on them, and as the water trickles through them rocks, bacteria is being removed.
That's why you always have to keep water flowing through the plant.
Yeah.
Because if it's not kept fed, those bacteria die. And it's very difficult to get them reseeded so you can treat them.
So where's the water go from here?
All right, so what it is, I'm going to take you to the lower building. The pumps that feed these are down below where we were in my office in the lab. Down below, you have Summit pump, which is a big force main that goes from here to Morris Avenue to Summit. And you also have the pumps that feed these filters. and also resurf, which feeds the tank down there. We put the owl on there because this is like a big bird bath for the birds. So if you park your car here and you come out, it's like it's been painted enough to come. So we've tried a lot of things, high pans, all different stuff, but really this is like a bird bath for the birds. We clean these filters twice a week. Somebody comes up on here, we'll turn the flow down a little bit, go manually clean the fins. Anything that's stuck in the orifices is removed. We pick the debris that gets on the filters, picked off. Once a month we grease the center column. That actually also acts as a barrier for the bearings, for no water getting in there. And that's how this works here.
Does the owl work?
That owl, no. I think the birds pretty much know. It's been here a long time.
We're going to have to get you a movable owl, one where the wings can flap a little
Actually, I even, at one time back, it must have been 10 or 11 years ago, I had one of those deer things that makes that little noise when it goes around, but nothing's really worked. You know, it is what it is. We clean it. Most of the time it's full with, with bird feces. So, all right, we have here, but this FCC 300, this is really our main process control panel for this whole plant. Same thing, motor controls, VFDs behind you for all the different pieces of equipment in this building. What you have is same thing. This really has everything on it. So if we have a power failure, basically you're going to see that the generator is running and JCP now power is basically not going to be available to us. This is the 2 communitors that are running. We need to change one of the bulbs in here. This is one of the low lifts that's downstairs. Transfer pump, which is feeding the plastic filter. Summit pump, which is running. Primary tank arm is turning. So this tells us everything. When we leave here at night, this is put in unattended, so that if we do have an alarm at the plant after hours, it's going to call out. And basically what you have in here, this is a dialer. The numbers are programmed into this to make contact with all of us. It goes through a process. Very important that this thing is operational and the phone line is operational. And we have had issues when it rains with the phone lines here at the plant. There's a history with it. Same thing, processor. This is the brains of the plant. Joe, can you see where? And you have all your cords here. Battery. This is DC backup. In the front here. In the front here, I'm able to go in and basically see what the levels are of the plant. I can go in and make changes to, how I want the pumps to run, the levels in the primary tank. This is basically where it's controlled from, right here. This is our check valves downstairs. They're pneumatic valves. They're controlled basically by air. This is telling us that it's open and closed. The Summit pumps, only one can run at a time, so we have the ability to move 2 million gallons. You can never run them together and blow the line up. So one is always running, and we have the other one as a backup. We switch them once a month to even the wear out on the parts, the pumps, and all that stuff. We try to do that with almost all of our equipment here, where we're switching it so that we even out the amount of hours that are on those pumps, especially when they're rebuilt. And this is something I'm going to try to implement over in Summit. I think it's so important at the 2 big stations. I'm not worried about the 2 little ones as much, but I need that same ability, and it's not there yet, but they're saying that they'll definitely do that. So, when it's pouring rain out and I'm home, I'm able to go on my computer, tap in here, and I can see what the tank level is at. The primary tank, if it's up to 300, I know I got to start driving here and get here. Tells me, the Constantine, and it basically goes through all of the processes in the plant. That's what the sump pump is pumping right now, 1.83. You know, the plastic media filter is not working because of our chart. And second stage, which is feeding the rock filter. This would be the flow to the river. And this is our second stage wet well for a rock filter. This is our rain gauge. This is basically how much rain we got last night. 3/4 of an inch. So, you know, every day we check that. If you look over here in the lab, Armin, you were asking me a question.
Yes.
These are called Imhoff cones, and I think I got that right. Basically, you know, you're taking your sample. So this is what's coming into the plant. There's not a lot of solids in there when this sample was taken this morning. But normally we average, you know, you'll see this at 7 or 10, and then this is what's coming out of the filter, which shouldn't have them same solids in it. We have a little bit here. With the temperature change, you start getting sloughing and stuff like that off the filter, and you'll have a little bit more debris in there. But normally this is pretty clear, and that's really coming out of the secondary clarifier we're taking a sample from, because we don't have an effluent unless we're discharging to the river. So, but that kind of tells us that our process is working in the plant. Temperature changes have big impacts on the filters, you know, as far as some of the bacteria sloughing off and you know, changing over. So at this time of the year, that's what we usually get. We'll get a lot of solids coming out, and it'll clear itself up when we get into a little bit colder weather. All right. These are summer pump lines. That's basically 2 million gallons that runs from here to Morris Avenue in Summit. One of the more important pumps that we have here, obviously we have one, you know, 2 pumps, a lead and lag. This is what draws off, this is the aerator. This is what draws off the primary tank. This pulls the sludge from the tank. We have cutters inside of here. Basically we're reducing the force main line after the job. It's taken away with that force main. Air compressor has to do with the bubbler system for second stage wet well. Our pneumatic valves up here are run by air. Pumps right here, they feed the plastic filters. 2 transfer pumps. And our 2 pumps here, second stage, they feed the rock filter. Where the flow is being generated for those filters. That's what you were missing. That's just the packing, the packing in the pump. We got to repack all these pumps. We have to repack and use SBS packing. Depends. We get 6 to 7 to 8 months sometimes, so we have to repack them or we'll have adjustments. Used to use seal water down here. We went to SBS, Dan went through it back, had to be, you know, early 1990s, and we've had a lot of success with it. So we've been using it on everything. It eliminated the seal water, and like I said, if you do a good package job on a pump, the sleeve is not really warm, you'll get a good 8 months, 6 to 8 months out of that one package. I just wanted to show you a couple things before we leave here. I talked about this as far as sewer blockages. Obviously, we have, you know, we're with the technology. We have a camera to video inspect these sanitary sewers, and we have a very good sewer jet with a vacuum capabilities. And they run together normally. You know, we'll have the jet in on this side, the camera on this side. We got a pair of headsets where the guys can talk, and basically we're running together. If there's a root mass there, the camera can tell the operator exactly where to be, what to do. Really awesome, awesome way of doing it. When I started back in the day, really it was just a blind thing. You'd go out with the jet. Most of the time you were probably punching a hole in the problem, and it would be good for a little while, and you'd be back there in a couple months. Now we're able to really clean these lines out real efficient and effectively.
Well, that's because
Those pictures up there were from the old camera too? The new cameras.
Yeah, the new
tremendous.
camera's a lot better.
Now, if you come across the roots and you grind them out, do you have to then reline that area?
It depends. I mean, if you got heavy roots like this, now this was up on Ryder Lane and Southgate, up in that area. A lady's basement did get flooded, but the reality of it, this was the blockage that was in there, but the reason she got flooded is because the guy that from Roto-Rooter came and took her sewer cap off in her basement and basically could not get it back on because all that hydraulic pressure was basically looking for a place to go, and when he took that cap off, that's what happened there. This has since been lined, the whole section, because we had roots in multiple places, and this is actually a weird setup because it goes from the road into the woods and then goes down along the woods and comes back out. So this is kind of was a maintenance headache. So by lining it, I'm sure that we took care of some infiltration in this area, but we eliminated having to go there on a bi-yearly basis and clean that system. This next picture is of one of the sewer crossings, and I wish I would have had time to put the other picture up because we have since ourselves these piers, we redid these piers. We actually went over, we put rebar in, you know, drilled holes, we formed these out, and we basically went over the top of the pipe in all of these sections, and this has been lined. This is down at the end of Ridgeview. We have one up by Edward Court. We have another one in JC's Park. We have a couple of these, but you can see when we get heavy rains how the debris builds up in them areas as it comes down through all of town. It's coming down here and we're catching all the debris. So we basically got to go out there with a boat. We have a bunch of hooks that we can throw out there with the equipment, and we'll clean this. And what you're looking at is when it was dirty, and then this was right after we cleaned it. When we got our new aerator, instead of having somebody come in and install it, we did it ourselves. We try to do that with everything. If you brought somebody in, it probably would have cost you $8,000 to $10,000 to have somebody do that. We were able to do that. This is when Joe first started, snapped the thing by mistake off the force main line, which created havoc. Right, live and learn.
Out already.
Yeah,
It was a good thing.
This was a big thing because we had to shut the force main down, and we were able to, you know, repair it. Instead of calling a private contractor in to come and do this, we do it ourselves. Channel Monster. This is actually a recent picture because this came out of Chatham Road and Summit. We found a sign wedged inside of this thing, an aluminum sign, and obviously the chain was really bad and off the sprocket. It wasn't working. We brought it down here. We redid it all. You're seeing we cleaned this all out, took all the sprockets off, inspected everything, and then put it back together. That's back in and running up in Summit.
It's actually filled with sewage.
Yeah. This is, Joe did this here. These are air relief valves for the air relief chambers that we have going for all our force mains. And you can see when it was taken out, the condition it was in. And Joe did an unbelievable job on this. He basically, if you've seen the inside, and there are pictures of it, this stuff was like brand new. We replaced a lot of this stuff to brass so that we don't have to worry about the rust. And basically that was the end result of that. Manhole repairs we do ourselves. This is just a picture of one of them. We've done a ton of them where we went out. We also have locking covers and stuff where we think they're necessary. Pump rebuild. You're looking at the Summit pump that we just seen downstairs. Here's you know, a new shaft, which we don't normally replace, but we needed one here. You have a sleeve here that sits in the stuffing box. It's like a sacrificial lamb. You see the new bearings. There's a upper and lower bearing, and that basically would go down into this housing where your impeller would get mounted. We would adjust the clearance on the wear rings and stuff for these pumps, and you know, your wear rings you want to stay on top of because the pump becomes less efficient the bigger the gap gets. These are actually the force main pump. These are actually the air relief pits for the force mains. We have 7 of them. we have to go there. What happens is they get water in them and stuff, and we don't want them to get up above this because that will be the end result. So we got to kind of stay on top of these chambers and suck them out, and keep the water levels down.
How often do you inspect them?
We try to run through them at least once a month. And then, this is just a picture of some of the training that we have to do here. Obviously, lockout.
Confined space?
Yeah, this is confined space. We actually combined this with Summit, and did a whole thing where, we made entries into the manhole. We did rescue up in the upper building. That's all. I could have put a lot more pictures. This is all I really had time. And I just want you guys to see that, we really go above and beyond as far as trying to do everything in-house here. Hey, what's up? We go above and beyond to do everything in-house. I think it's a huge savings for the borough to have guys that can do this kind of work. We enjoy doing it, actually. All right.
Well, we appreciate the tour, Tony. And
well, you got a couple more things, right? You got to see this one last thing. You done? If you guys want to be done. These are our chemicals that we use when we have to discharge to the. This is the chemicals that we use when we have to discharge to the river. Hypochlorite, basically, will kill 99.9% of the bacteria that's in the water when it gets through. Obviously, if you have a lot of solids in the water, it depletes, the efficiency of this. So, that's why you're going through this process. And when it gets back to the chlorine contact tank, this should kill 99.9% of any bacteria that's in that water. This here is sulfur dioxide, which basically neutralizes the chlorine. So you're going to have your hypochlorite, your water treated with hypochlorite coming in. When it goes over the weir, it goes into this pit. This is a gas that's carried by water back to another chamber in the back. When that, water that's treated with hypo goes into that chamber, it's hit with this, which neutralizes the chlorine, and now you have no chlorine residual going out to the river. So now this is, we have to stay on top of this stuff because we don't use it all the time. So we try to come in here once a month, run these pumps, to maintain the equipment. If you just let it sit and you never touch anything, and then you go to use it, it's not going to work for you. So we have to, be aggressive in making sure that this stuff is ready to operate when we do have discharge events. And that's it for here. Well, because, my feeling is you to carry this gas, you basically, you have to have these heaters for the gas to be effective. So this one's plugged in right now. It really should be unplugged because there's no sense in keeping these on if we're not going to be using the gas. So if we know we're going to have a hypo event, if we're going to have a discharge event, we'll turn the hypo on, and it's induced just past the secondary clarifier. And when you come in, you want to plug the heater in at your side you're going to use. And if you don't have that heater on, this is not going to work.
How much time do you need?
About a half hour.
About a half hour.
But usually, if I come in and I know we're at a point where we're most likely going to have a discharge, I come in here anyway and run the pump with water. That one tank's filled with water just to make sure everything's going to be all right. We got a good prime. And then we'll plug this in and get ready to go.
Have we ever had to use the safety equipment here?
By mistake a couple times, but no, so far, no.
When I first started working, I was like, let's see if this worked. I pulled it, I didn't realize this was the alarm inside. It sets off the whole panel.
So let's see, you broke for one.
And here's the thing.
Can you just use to deal with that?
One of the big things I think happened with this tank, we used to discharge to the river every day, all the way up into the mid-90s. This tank was always full. We decided to use it more as a storage facility. And then, obviously, we're exposing it to the weather conditions. You have your ports on your side for, water pressure and stuff. But this tank has definitely shifted. We're gonna, we put this out to bid 2 years ago, and I think the lowest bid was out to 26,000. I think it was a mistake because I think the people that bid on it really didn't come and look at the job. Only one person did, the guy, the lowest bidder. I think they thought we wanted to replace these whole arms, but all we wanted to do was change the plates on the bottom. After the floor was screwed down, we wanted to change these plates. So I think it's a good time to put this back out. Price-wise.
People looking for it.
So I was going to talk to you about that anyway, about putting this back out. Because we can always turn the bids down.
Is the water always running there?
Yeah, that's coming out of the rock filter right now.
Oh, okay.
And then what would happen is if this tank is filled, this is the same kind of tank that's in the middle, but you have a lot less solids. So the refined solids will settle to the bottom.
Right.
The rate arms will bring it into that hopper, and then that sludge is sent back to the head of the plant. If we do redo the tank, I'm actually thinking about keeping this half, try to keep this filled up. And then when we're going to get a wet weather event, drain it back down. And that'll probably...
Well, if we use clean water, we could use like a swimming pool until we need it.
I don't know about that.
Got that one again.
All right, here's what happens. So now our primary tank in the center has filled up and it's going over. It's filling up the secondary clarifier. Now the secondary clarifier is going over. What'll happen is the flow comes out of that pipe right there in the center, that big pipe down below. And a lot of times we'll get lucky and we'll be able to recirculate, and the water will go back up through this sluice gate where you see the little valve down there with the pipe open. The water will come around, go down that pipe, and we'll just keep recirculating for as long as we can. So the flow coming out of the secondary clarifier comes into here, and we'll just keep bringing it around. If the flow is too heavy, it'll eventually go up over that wall right here, this little separation wall. And when that happens, we basically got to shut this valve. We go and turn our hypo on. The hypo's induced. Mike was just over. There's a manhole on the side of the clarifier. That's where hypo comes in. Now the water coming through here has hypo in it. It basically goes through this process. The reason you see the wooden baffles is for contact time for the chlorine to do its job. So it's going to go through there on a slower thing. And then as we walk around here, so now you have your wastewater that has hypo in it. It's going to come up and go over this weir right here. When it gets over this weir, this pipe that you see down below is where the sulfur dioxide is induced into the hypo. So you have your hypo coming over the weir. There's your sulfur dioxide line. Once it gets into this pit here, basically there should be no residual, chlorine residual, and that's testing that we have to do on every hour. We're testing how much hypo's in and make sure that we don't have a high residual. These two tubes that you see are for our composite samplers. That's our effluent right there. That's where we're getting it. This is our discharge pipe right here that goes to Passaic River. Now, when we had Hurricane Irene, and you guys will be getting a copy of it, I had to write a letter of affirmative defense to... Oh, you seen it already? Basically, you know, the water was up to this edge right here. So if you looked at the picture, this tank, kind of basically neutralizing our sulfur dioxide. So we had a mixture of samples. I thought the pictures, you know, were 1,000 words having those pictures to show them. And I'm sure a lot of treatment plants had the same issue.
How often do we use this tank?
This tank, whenever we have wet weather flows, we basically use it.
And what's the holding capacity here?
This whole thing,
Yeah.
this is about, I think about 150,000 gallons in this tank right here.
So do we have the capacity to hold approximately 650,000
tank-
gallons between?
This tank here is really just a transition. I mean, once you get to this tank, you're basically going to the river.
Right, yeah.
So our biggest thing is between the primary tank and the secondary clarifier, if we can get it back here and buy enough time to just keep recirculating, most of the time we can avoid an event. We probably avoided 4 or 5 events this year by using that process.
Right.
But sometimes there's no way to stop it from happening. One of our big things too is, you know, obviously when we have the event, because if we have it on a Friday and it goes into a Saturday, some of the testing that has a hold time of 24 hours, we can't get that sample tested in enough time. We drive the samples down that have 6-hour and 24-hour holds, but we've run in some of the testing that has to be sent out for asbestos and stuff like that. We've run into some issues, and the state understands. I've written them letters explaining to them the situation that we're in. We're not going to keep a discharge event going. If we could stop it on Saturday afternoon or Saturday night, we're not going to keep it going until Monday morning just to meet that one parameter that they're asking us to test for. So, and then right over here, at one time there was ultraviolet lights in these channels right here. We were kind of the guinea pig for it at the beginning when Fish Reporter first brought them out. They became like a boom. We were like the place where people would come and look. They were a nightmare. I know they've come a long way with them now, but we used to have, I used to have to clean the quartz lenses, you know, every couple days. Each channel had 9 racks in it, and the connectors were always shorting out and stuff. So we went to this system, and then these are our composite samplers. These are polar composite samples for testing. Same thing that you've seen downstairs. We have 2 of them because if one of them ever fails, we run them both anyway. But if one of them ever fails, at least we have a backup, because I mean, that your requirement to the state is that you are going to get a 24-hour composite and you're going to run your testing. The drum in the back is to control foam. It's a defoamer. We don't want you know, foam running down a river, big things of foam. So if we start building foam up, we'll turn that on, and basically as soon as that stuff starts hitting it, it keeps the foam from being able to form. And that's the end of this process right here.
Thank you
So where does the water go after everything?
Goes to the Passaic River.
Just right at the Passaic.
Yeah, right here, and then it makes its way down, and ultimately, you know, American Water and stuff, they draw off the Passaic to process their water. So it's a different process for potable drinking water, but we're making the water to the standards that the state requires for us to put it into the river, and we're meeting them requirements, and that's you know, that's our biggest objective. To be ready to be able to meet them requirements when we do discharge to the river.
Very good.
The advantage with this thing is I can control the whole thing from right here. Now, I'm controlling the whole reel, everything from right here. The camera has got lights, there's all different attachments for it, but you can also, it's got a zoom on it now. So you don't have to try and get real close to stuff, especially it comes in handy when we're cleaning. So you don't have to be anywhere near the jet while you're inspecting. As far as you can change your aperture, everything, and that's not, I'm not raising lights, I'm just changing the iris setting on it, and the speed of it. Our old camera, you could do a maximum of, was it 400 feet a day? This thing, I can easily do over 1,000, easily over 1,000, 1,200 feet a day. The old camera was at the very most you're doing 400. It was so slow, and the old one you couldn't steer. You couldn't look around things. This has got sonar built right into the camera, and this whole setup really is a portable setup. Right here, this whole unit can come out, and I could bring it in the back in the woods if I needed to. What we did is we retrofitted the ambulance and built all this stuff here and did all the wiring ourselves, rather than, because I mean, to get a camera truck nowadays that has it built in like this, you're talking like 250,000.